I was just asked, Calvin and Talon asked me if I could talk about this new device that we've just finished getting a patent on in Oregon that's going to be rolled out to the seed industry there to determine seed moisture rapidly. So just got a couple quick slides here and show you guys what this is about and tell you how it's going to work and when it's coming. I think the clicker's not working. There we go. So just real quick, the reason that we need to test seed moisture is because we know that the breeding for shattering has not occurred in the cool season grasses that we grow yet. And it can often be tricky to figure out when's the best time to harvest when you know that you've got adequate germ and yet you're there before you start shattering seed. And we know that these fields are often have high levels of variation and uniformity, so it can be pretty tricky at times to figure out when to cut those fields. And that's the case of Oregon, where really determining when to swath is the important decision. But if you go places like here in Western Canada, Europe, certainly this summer in New Zealand, you get these rains during harvest, and you also want to know what the moisture is in those windrows. So you can know if you need to leave them to dry longer, and you may also want to know moistures in the warehouses or in drying facilities if you've been drying. And so when we talk about shattering in terms of for the farmers that are in the room, there have been several efforts to measure what we lose in shattering done both in New Zealand and by myself in Oregon. I think we're only losing probably 7 to 10% in the fescues, but both my data and the data that's come out of New Zealand shows we're somewhere around that 25% in perennial ryegrass that we lose just in the swathing process. My suspicion is that's even higher in annual ryegrass. And so far, if you think about wheat, that's a domesticated grass where you don't really worry about the kernels falling off of a wheat head, and that's because shattering has been bred out of those grasses. Well, in the case of the forage grasses or turf grasses that we grow for seed, that has not occurred yet, and I continue to have that conversation with all my breeder friends, so we'll get there one day. But in the meantime, determining seed moisture is still really our main tool to figure out the correct time to cut so that we're ensuring high seed quality but not losing a whole lot of money on the ground, which unfortunately I think is what's happening now. So the problem with measuring seed moisture is that traditionally it's been an extremely painful process where you have to go out to the field, sample, strip the heads, bring it back, weigh it, dry it, weigh it again, and then do math. And at least in the case of Oregon, where most of the farms are dominated by grass seed production, they start combining before they're done swathing, and they're pretty good about taking seed moistures at the beginning of harvest, but then once it gets going, the wheels kind of fall off. And you just start doing drive-bys and hoping for the best. So actually, it's been about 8 or 9 years ago now. Tom Chastain, who's a retired seed crop physiologist now, and myself set out to see if we could find a way to make that process faster using NIR. So NIR is near infrared spectroscopy, and basically what that does is it looks at certain wavelengths that correspond to water molecules, and the amount of light that is absorbed at those wavelengths can be directly related to seed moisture content. So of course, NIR has been used in cereal grains for many, many years, but as you know, those are tested at really low moistures, and we're often looking at much higher moistures in forage and turf seed crops. So Tom and I found a paper, it's probably been 9 or 10 years ago now, where they had been using NIR to work on dairy silage. And we thought, well, it would be interesting to buy this sensor, which was about $7,000 at the time, and go out and see if we could get it to correlate in grass seed crops. And so we did exactly that. We set out on a couple different species. We were sampling 7 days a week for a number of years. And we essentially found that there were really high levels of correlation. So here's examples of tall fescue, annual ryegrass, perennial ryegrass, and creeping bentgrass. So what we would do is go out and sample a field from the time we could find a viable endosperm until right when the swathers would hit, and we would quickly take NIR measurements using the silage NIR tester, and then we would put the samples in the oven, dry it down, and do it the old conventional way, and then try to understand, is there a relationship between the two? And there is actually a very strong relationship. For work like that, these R-square values are quite high. And so that gave us a really good indication that we could actually use NIR. Unfortunately, once we felt like we had enough data to feel confident in this, the company who was making the dairy silage tester decided that they were not going to make the dairy silage tester anymore. And so I thought that we had wasted about 6 or 7 years worth of research. And right around that time, OSU decided to hire a precision ag engineer who happened to have a PhD in sensor technology. So Dr. Jing Zhao is my colleague in Oregon, and I was actually the chair of his search committee, so I knew exactly what he knew how to do. And his first week on the job, he said, I have a project for you that's ready to roll. I have the data, but I have no idea how to build electrical circuits. And so essentially, Jing and I have worked the past 2 years to create our own sensor that's actually more relevant to grass seed crops. It's better designed for doing what we do than a big silage moisture tester. So we've named this the Grady Sensor. Basically, it's a handheld device. I have one in my bag back there in the back of the room if anybody wants to see one up close and personal. But you still go to the field and strip heads. You fill up the cup of seed. You attach the seed to the back of the device. And in the case, if you were wanting to do this in a windrow, you would do the same thing. If you were wanting to do it in a warehouse, of course, you just take a sample, fill up the cup. You attach the seed cup to the back of the device, and there's LED lights that are at very specific angles that are projecting wavelengths down onto the seed. And then there's a photodiode that is receiving those wavelengths and pushing it up to the sensor. And then we have come up with the algorithms of the correlation between the wavelengths and what the actual seed moisture is. Now I'll tell you that those algorithms are not the same for grass seed. All grass seed is not grass seed. So it's a different equation for tall fescue than for creeping red fescue. And it's a different equation for perennial ryegrass and annual ryegrass. So we've basically put that into the housing, and how this thing is going to work. It's basically a handheld device. It has batteries in it that are pretty long lasting. You can charge it like you would charge a cell phone. So it's got a USB-C port in it. Once you put the cup that's full of seeds onto the device, on the screen, it's a touch screen. You will pick the grass seed species that you're dealing with. So if you got red fescue, you pick red fescue. And then you push a button, and within 5 seconds, you get the moisture of that seed. So no more cooking or microwaving, no more weighing, doing math. And the cool thing is that it can actually, it's got GPS on it, and it can drive around with, a seed company rep or even a grower. In Oregon's case, there's big growers. It's also got Bluetooth capacity, so if you want to send data to a customer or whoever, you can do that. You can also store the data, so you can send it to a phone or an iPad, whatever's got Bluetooth capacity, and track things. The other good thing that the Bluetooth does is it allows us to push updates. So on your iPhones, you get updates, you get a message that says run an update. The same thing will happen here. So as we add other species, you will get a message that says run an update, and then there will be new species added, or perhaps we make the curves even better than what we have them now. So here's basically the information. It's not a cheap device. It may be cost prohibitive for some individual farmers in a seed market like we are in now, although I think there's quite a few Oregon farmers that are planning on starting to use this. We are going to roll it out. So we have, the patent is held by the university, and we have come up with enough funding to produce 50 before harvest in Oregon this year. So we're gonna release those pre-orders in April, and basically it's a pay-to-play system. So the individual farmer will buy a cheap license, and the nutrients that are out testing hundreds and hundreds of samples in a year in Oregon will pay a different level of licensing. So trying to keep the cost as affordable as possible for the average person, yet the companies will pay more based on how many samples they're using, so or measuring. So what we will have on the machine by this harvest is perennial ryegrass, annual ryegrass, tall fescue, creeping bentgrass, orchard grass, and I'm pretty sure, we just got back from a month of collecting data in New Zealand, I'm pretty sure we're gonna have Timothy on it by this summer. It will be another year before we have Kentucky bluegrass and creeping red fescue, and we'll also have Turing's fescue on there. So we have to finalize that data this summer, and then we'll have those added. So anyways, just wanted to make you guys aware. I think this is coming out. It's for sure happening. I think it can be sold around the world. We've verified that we get the same data. The relationships, at least between Oregon and New Zealand, appear to look the same. So we have gone to different environments to rule out that there could be an environmental influence. So there's a QR code there you're welcome to take a picture of. You can put your name on a list where you just get updates. It doesn't, you're not gonna get pestered or anything, but if you wanna track when it's available, that's how you do it. So that's all I've got.